These are the solutions to question number 2 on the 2017 Linear Algebra Summary Examination paper. So two-part A is concerned with lines in three-dimensional space, and question 2B is concerned with a plane in three-dimensional space. So for question 2A, we have the two lines L1 and L2. I want to try and determine whether or not these lines intersect. So if we equate components, we get these three simultaneous equations. So we have 1 plus 3r is 3 minus s, 1 plus 0r is 1 plus s, and 2 take away r is 1 plus 2s. And we have to satisfy these equations simultaneously. Now if you look at equation 2, you'll see that gives s is 0. And equation 3, using s is 0, gives us r is 1. And if we plug that into 1, then we get a contradiction. So therefore, these lines do not meet. So there is no solution to equations 1, 2, and 3. Next, we want to find the shortest distance from the point A is 115 to the line L2. So what you could do is either look it in your notes and find a formula, or you can follow this solution here. So suppose x is perpendicular point on the line. That's 3 minus s, 1 plus s, and 1 plus 2s. So the vector ax is given by 2 minus s, s, and minus 4 plus 2s. So this vector is then perpendicular to the line, which means that the dot product of this vector with minus 1, 1, 2, that will give us 0. And 10 minus s is 0, so that gives us s is 5 over 3. So x is equal to 4 over 3, 8 over 3, and 13 over 3. So ax, remember, is the vector x minus a. And then the length of this vector, again, we find the norm of this vector, which gives us root 30 over 3. Now to find the Cartesian equation of a plane, then we take two vectors which lie in the plane. So for example, we can take b minus a will give us a vector in the plane, and c minus a will give us another vector in the plane. So if we take the cross product of these two vectors, that will give us the normal vector to the plane. And then these coefficients of I, j, and k for the normal vector give us the coefficients for x, y, and z in the Cartesian equation of a plane. And we don't know what p is. So all we do is we plug the coordinates of a point in the plane. So any of these points in the plane, we plug them in, and you'll see that we get p is minus 65. So the Cartesian equation of the plane is 4x plus 5y plus 25z is 65. And that concludes the solutions to question number 2.